Hello everyone, welcome back to this channel. In the previous video, we started with the sliding window pattern, that is with the fixed window. There, the window size was already known, but most of the problems are not that simple. So today we will move to the next problem, that is based on the variable window, that is where we will understand the real power of the sliding window. So let's understand the problem first. So this is the problem which I have taken today, that is the fruit into baskets. Firstly, let's read the problem statement. The problem statement says is that we are given with an integer array fruits and where each of the element represents a type of fruit on a tree, and we are allowed to pick the fruits under the following rules. There are some of the rules. Let me just read them out. So we have two baskets, and each of the basket can hold only one type of fruit. A basket can hold any number of fruits of that type, and we can pick the fruits only from the contiguous trees. That is a subarray in the array. So what is the task of this particular problem? The task which is given to us is that we have to return the maximum number of fruits which we can pick by choosing a contiguous subarray that contains at most two distinct fruit types. So let me just explain this in brief. This is the problem which has given us the array, that is the fruits, and whatever the elements are present in this particular array, each element represents a type of fruit on our tree. So as we are having an array fruits, so we can call it as fruits of I. So fruits of I is representing a particular tree on that particular tree, that particular element is representing a type of fruit, and we are allowed to pick the fruits under some of the rules. So first of all, we are given with the two baskets. Let's consider those baskets as basket A and basket B, and each of the basket can hold only one type of fruit. So for example, let's say one element is there, by the let's say represented by 1, that is one type of fruit, and another element, let's say 2, that is another type of fruit. For example, 1 is coming in the basket A, so now no any other element can come in that basket because it can hold only one type of fruit, that is 1. And for example, in basket B, let's say 2 is coming, so now no any other element can come in that basket B because only one type of fruit can only be there in that as well. So therefore, in both of those baskets, each basket can hold only one type of fruit. Let's say in basket A, 1 is there, in basket B, 2 is there. Now another thing is that a basket can hold any number of fruits of that type. So as I told that if 1 is coming in the basket A, so 1 can come any number of times. If 2 is coming in the basket B, then 2 can come any number of times. That number is unlimited. And we can pick the fruits only from the contiguous trees, that is a subarray. We cannot skip the trees. We will have to pick them from the contiguous, we can say a subarray in the array, or we can say the contiguous trees. We cannot skip those trees. So what is the task given to us? We have to return the number of the number of fruits, maximum number of fruits which we can obtain after picking by choosing a contiguous subarray that contains at most two distinct fruit types. See, if we have to make this particular problem simple in order to solve, so we will have to narrow down the things. We can see here that the baskets are given. So just ignore these baskets for a moment, because this problem is not about the baskets. We can see here that we have to return the maximum number of fruits which we can pick by choosing a contiguous subarray. So we can see that a problem is about the subarray, a contiguous subarray, and it is saying in order to maximize the number of fruits. So for that, we can call it as the longest subarray. We have to find the longest subarray, where what is the condition? The condition is that we have that particular subarray should contain at most two distinct fruit types. Here, what are the fruit types? Fruit types are nothing but the elements. So we can just restate this particular problem or convert it into a simpler version, that we have to find the longest contiguous subarray which is containing at most two distinct elements. That is the problem all about. We can see here that the problem is not about the baskets and all. The problem is simple, that we have to just find a longest contiguous subarray where the condition is simple, that it should contain at most two distinct elements. That's the problem statement, very simple. So let's just see some of the points here so that we can get to know more about this problem. The real question which we have already discussed, that it is about finding the longest subarray with uh, at most two distinct elements, means less than equal to two distinct elements. Now just notice one thing here, that in the previous problem we have solved for the fixed window, means we already know that the window size was already fixed, but here we don't know in advance that how many fruits we have to pick. Okay, so we don't know that what will be the window size. So here the window size is not fixed, therefore this particular problem is a part of the variable sliding window. Okay, And another thing is that whenever we comes with the sliding window problems, there is only one thing we need to know at every point of time when we are solving a problem. We need to know that the window is valid or not. And here the window validity depends on this simple condition that that particular window must have the distinct elements, means at most two distinct elements. So therefore the window validity condition becomes here that distinct elements less than equal to 2, means at most two distinct elements can be there. Now, after having this particular observation of window validity, a quick question comes into our mind that how do we know that how many distinct fruits are present inside the window? So for that, when I have solved this particular problem, initially I thought of a set, that maybe I can use a set because I only want the distinct elements, so I can get to know with the help of set. But later on, when I came across the multiple observations, I get to know that set is not sufficient in itself, because set can only tell the presence of the element, not about the element is present later in the window or not. Okay, because in this particular problem we need to know two things. One is that how many times a particular element or a particular fruit type is available, and second thing is that that particular fruit type should be removed from the window completely whenever its count or the frequency is 0. So that thing can only be answered with the help of frequency map, not by the set. So later on, I just came to know that set is not sufficient. The frequency map is only used in this case. And I have also mentioned here as well that the frequency map is used whenever we have to track when a fruit type is truly leaves the window. And that is the only purpose of using the frequency map here. The set cannot be used because it cannot answer all the things. The frequency map can. Now let's understand that how the window is maintained in this particular problem. So first of all, we have to use the two pointers here in order to have the boundary of this particular window. So the left and the right pointers, both of them will be pointing at the 0th index, means at the start, and at every step we will just increment the right pointer in order to expand this particular window, and then we will be checking for the validity, that if the window is valid or not. And I have already told that when is the window valid, means if the distinct elements are less than equal to 2 or not, means at most two distinct elements. And after checking this validity, if it is invalid, means the window is not valid now, so we will have to rebuild that particular window in order to keep it valid. And for that we will have to shrink it from the left, and that we will see more, that we will be understanding more when we will be performing a dry run. These all of the things will become more understandable when we will come to the dry run. So in case if the window is invalid, then we can just shrink it from the left, and if it is valid, then we can just update the answer, means whatever the length of that particular window is there at that point, we can just update that particular answer. So this is all about it. And now let's just take a simple example, a kind of test case on which we can just perform a dry run, and then we will come to the implementation part, and along with its analysis of the time and space complexity as well. So this is the example which I have taken, and now let's just perform a dry run here. So first of all, I will be taking the two pointers, left and the right pointer, which will be pointing at the 0th index as of now. So this is the left pointer, and this is the right pointer. Both are pointing at the 0th index. This is the left pointer and this is the right pointer. And now I'm taking the frequency map, and after taking just while performing the dry run, we will get to know that what is the actual purpose, what is the actual use of this frequency map, whatever the points we have discussed earlier. So here let me just take the frequency map here. So this is the frequency map I am taking, and let me just name it as frequency map. Okay. Now let's just perform a dry run, and we will get to know that how the things are working. So here, first of all, this right pointer is pointing at this 0th index. So we will come to know that, okay, 1 is present here. And now we will keep this 1 inside the frequency map along with its count. 1 is present one time as of now. Now we can check for the validity of the window. So we can see only one distinct value is present, one distinct element is present. So therefore the window is valid. Now this, for this particular valid window, we can have the length of this. A kind of subarray. So for that we can just maintain a particular variable for that, and that is 0, let's say, initially. And right now the window is valid, so we can just have the length of it. How we can get the length? That is means many of the times I have told that right minus left plus 1. So that is 0 minus 0 plus 1, that will be the length. So 1 will be the length now. So the answer will be updated with the value 1. Okay. This is the answer, means till now we have got a valid length or the subarray length of 1. And now we can just increment this right pointer in order to expand the window. So now the right pointer is pointing at this first index where the element 2 is present, and now this 2 will come inside this frequency map with its count. So now 2 is present for one time. Now we can again check for the window validity. So we can again see that inside the frequency map means two distinct keys are present. So therefore the size of the frequency map will tell us that what are the distinct elements present. So therefore we can see that two distinct elements are present. It means the window is valid as of now. So again the window is valid. So therefore we can have the length of it. So again right minus left plus 1, that will be 1 minus 0 plus 1, that will be the length 2. So the answer is updated by 2, means whatever the maximum length is there, because we have to get the longest subarray. Now again this right will move ahead, and when it moves ahead it will check for 1, and here the window is again valid, because we can see here that only two distinct elements are present as of now, at most two distinct, and this frequency of 1 is again incremented, so it is 2 and the window is valid. Now again window is valid, so therefore we can again update the length. So that will be right minus left plus 1, that will be 2 minus 0 plus 1, that is 3. So answer will be updated by the value 3. So therefore we have got the subarray, the maximum length subarray till now of length 3. Now again this right will move ahead and it will check for 3. So it will now update this 3 inside the frequency map with its count. So 3 is now present in the window for one time. And now we will check for the window validity. So now we can see that the window is not valid, because it is having the three distinct elements. So therefore we will have to shrink this particular window in order to rebuild it, in order to make it valid. So the shrinking of this particular window will be done with the help of left pointer. One thing which I have missed here when I was talking about this frequency map is that whenever we are shrinking this particular window, in that case only one occurrence of the element is removed, not all the occurrences. We can see here one is present two times, so only one occurrence will be removed, this particular occurrence at 0th index, not of the second index. Okay, that we will get to know when we will perform here the frequency map. So the thing is that the frequency map can only answer this particular thing, not the set. Only the frequency map can tell that if there are any other occurrences later in the window present for that particular element. So this is the thing. Now let's just shrink this particular window, and here for this one, the shrinking will be done and this particular occurrence will be removed, and only one occurrence will be removed. You can see here one is still left, one occurrence of this one. So after shrinking, this left will be moved ahead, and now we can see for the window validity, again it is having the three distinct keys, therefore three distinct elements, only because this one occurrence of 1 is still left, and still the window is invalid. Therefore we will have to again shrink this particular window with the help of left pointer. So again this left is pointing at this second, this value 2, so therefore the occurrence of this 2 will be removed from here. So we can see here that this particular occurrence is removed, so therefore it becomes 0. And the moment any of the occurrence for any of the key becomes 0, we will have to erase that particular key from the map. So I'm just erasing in this way. Okay, so this occurrences or this key is removed. Now this left moves ahead, and now we can see here that one of the key is completely removed from the frequency map. Why? Because its frequency is 0. So at any point of time, any key's frequency is 0, we can completely remove that particular key. And also it might happen in the case of 1 as well, like in future in this particular array, if this one's frequency became 0, then 1 will also be removed completely from this particular map. Okay, so now we can see here that the 2's frequency is removed completely, or the 2 key is removed completely. So we can now say that this particular window is valid now, because it is only having the two distinct elements, and the moment it is having the valid window, we can again take the length of it. So what is the length? It is 3 minus 2, that is 1 plus 1 2. But is it maximum? No, till now the maximum is 3, so we cannot update it. Now this right pointer will move ahead, because we have to now expand the window, because the window is valid. Now 4 will come, and it will come inside this frequency map with its frequency count, so that will now for the one time. Again we will check for the window validity. So again the same problem came, that the window is not valid because it is having three distinct elements. So again the shrinking will be done with the help of left pointer. So now left is pointing at this one value. So for this one, we can see here that the frequency is going, the one occurrence of this one is going to be removed. Now we can see here that the frequency of this particular one key is 0 now, so therefore it will be erased from this particular map. And once it is erased, we can now check for the size of this frequency map. It is 2. It means it is only having the two distinct values when this left pointer moves ahead after shrinking. Okay, so now again the window is valid because it is having two distinct values, so therefore the window is valid again. And again when checking for the length, it will come as 2, which is not maximum, so answer will be 3 only. Now in order to expand this window, right pointer moves ahead, and again it will check for 3. So for the 3, the frequency will be increased for this particular 3. So now the frequency becomes 2. And now checking for the window validity. So two distinct values are only present in this particular window because the frequency map sizes two distinct keys, two distinct elements. So therefore again we will check for the length of this. So length will still come 3, so it is 3 only. That's no point of updating. And now this right pointer moves again for the expanding the window, and now 5 will come. So 5 will be entered inside this frequency map along with its frequency count, so that will be for one time. This particular window became invalid because it is having 3 distinct elements, so therefore the shrinking will be done. Here the 3 is present, so 3's occurrence, one of the occurrence of 3 will be removed and it will become 1. So we can see here that after removing this particular occurrence and moving this left pointer ahead, we can see that one of the occurrence of 3 is still left. So therefore on checking the validity again for the window is still invalid because 3 distinct elements are there. So again the shrinking will be done and this occurrence of this 4 will be removed, and when it is removed, it became 0. And as the same, this 4 key will also be removed from this particular map, and when it is removed, we can see the size of this frequency map is again 2 after moving this left pointer ahead, where the window became again valid with the 2 distinct elements, and therefore this when we will take the length, it will again 2. So now right pointer moves ahead in order to get the value, in order to expand the window. So again this 1 will be coming here, and for the 1 will be entered inside this particular map, and again with its count, so it is for one time. Now again the window is invalid, so again the shrinking will be done, and for this 3 the frequency will be removed, means one of the occurrence of it is removed, and it is again became 0. So now the 3 key, the key 3 will be removed from the frequency map, and again checking for the size of this frequency map. So again it became 2 after moving this left pointer ahead. So again the window is valid in this case, and getting the length, it is 2, so answer is 3, that is a maximum. Again for expanding the window, the right pointer moves ahead, and now we will be updating this 2 inside the frequency map. So 2 now present one time inside the frequency map, so therefore it is updated. And now again checking for the validity, so again it is invalid, so therefore the shrinking will be done, and here 5 will be removed, means one of the occurrence of this 5 will be removed from here, so it will become 0. 5 key will be removed from this particular map. So therefore the again when this left pointer moves ahead and checks for the size of this particular frequency map, we can get to know that only 2 elements are present, the 2 distinct elements are present, which is making the window valid. And again we are having this particular window valid window, so therefore the length we will take, and it will be 2, and the maximum is 3, so the answer will be 3 as of now. Now moving this right pointer ahead, we can see here that no more indexes are present, so therefore the right pointer till it is n-1 index or less, till that point only we can just process these things. Otherwise the window is not going to be valid in that case, and we will just stop there and there. So therefore whatever the answer we got till now, that is the answer for our problem. It means we are having the longest subarray in this particular input array. We are having the 3 length longest contiguous subarray with the at most 2 distinct elements. Okay, so this is the dry run which we have seen, and now let's get to the code part and let's see how we can implement this particular logic. So this is the function which we have to complete, and let's just first get the length of this particular array. So that will be int n equal to fruits dot size. That will give us the length of this particular array. And after getting this, we will have to have the frequency map, that is unordered map, and we will take 2 parameters which of integer types, and let us name this as frequency map. This is the frequency map we are going to use. And now first of all what we have to do is we initially have to take the 2 pointers, left and the right pointers, which are pointing at the 0th index. So first of all, int left pointer, means left pointer is there which is pointing at 0th index, and also right pointer is there which is pointing at the 0th index. And what we have to do now after this, once we are having the left and the right pointers pointing at the 0th index, we can then start expanding the window, or like I can have the conditions. Let's see, see first of all till what condition I have to do this entire thing. Till the right pointer is pointing till n-1 or less than that indexes, and the moment it comes at n index, we have to stop that thing. So for that I can just use the while loop here, where right pointer will be less than n, and in that case I can have now the condition, some of the conditions. See, we are having this particular frequency map, and in this what will happen is when is the window becomes invalid, what we know is, so the window becomes invalid whenever the frequency map size is greater than 2, means we only want the at most two distinct elements, and whenever the frequency map size grows more than 2, then at that time the window becomes invalid. First of all, I can just have a simple condition that if this frequency map dot size is less than or equal to 2, it means till this particular point the window is valid. Okay, because it is having at most two distinct elements. So in that case, what I can just do is that I can just have the answer, means I know that the window is valid, so I can just have this answer, and I can just have the maximum of, so I will also have to maintain one variable, that is, let's say int answer equal to 0, which will be holding the maximum length of that subarray. So let me just call it as max length, the max length variable. And whenever I am getting that my window is valid, in that case I can update this with the maximum, means maximum of this max length till now, and whatever the right pointers, right, left and right pointers are there, so that is right minus left plus 1, so this will give me the length, and whatever the maximum is there, that will come inside the max length variable. I know that once I have get the maximum length for that valid window, now I have to expand it more, so for that I can just increment this right pointer. Okay, but what if the length, if this particular window is not valid? So what is the case for that? The window is not valid whenever the frequency map size is greater than 2, obviously. So for that I can just write the else condition in that case. So for the else condition, uh, what we have to do in order to make the valid window? So in that case, I can just shrink this particular window with the help of left pointer. So till what point I have to shrink this particular window? Till the frequency map size is greater than 2. So for that I can just write a while loop again here, where I will write a condition here that till the point this frequency map size is greater than 2, till that point you just shrink this window. Okay. So for that, how we have to shrink? Let's just take an example that this left pointer is pointing here and right pointer is pointing here. Now we know that this particular window is invalid. So in order to shrink it, wherever this left pointer is pointing, means for this 5 element this left pointer is pointing, so we will have to decrement this its occurrence, one occurrence of it inside the frequency map. So we will just go inside the frequency map, and for that element, how we can get that element? That is fruit of left. So that is fruits of left, and whatever that key is present inside the frequency map, for that we will decrement its occurrence. And once we have decremented its occurrence, now we will check that if this particular uh, frequency of this 5 is 0 or not, because we also have to erase it, because if we do not erase it, then we cannot get the window validity check. On checking the window validity, we will not get the correct results. We will have to erase it from the frequency map whenever its frequency becomes 0. So for that I will have to just keep a check here that if this frequency map is inside the frequency map, if this fruits of left, is equal to 0, and if it is true, means we know that this is 0. Now we will erase it. So how we will erase it? That is with the help of frequency map dot erase. What value we have to erase? That is fruits of left. Okay, so once we have removed it, now we can see here that this element, this particular key is not present inside the frequency map. Then we can just take this left pointer and move it ahead. Okay, so we can just write this left plus plus. Okay, so this left pointer now moves ahead, and then we will again check for the same condition with the in this while condition itself. That is the frequency map size is greater than 2. So we can see here the frequency map size is uh, equal to 2 only. It is not greater than 2. So therefore this condition now becomes false. Okay, and now once we get to know that this particular while condition is false, it means what? Because the frequency map dot size is less than equal to 2, it means the window is valid now. Okay, so now because the window is valid, we will have to again take the length of that particular window, or the length of that particular subarray. So for that thing, we will do the same thing. We will just take the length of that with the help of left and the right pointer. So we can just take its length here in the same way, the max length equal to max of max length, and the length how we have to get. And after that, once we get that particular length, we can just move this right pointer ahead. So for that we can write the same way, the right plus plus. Okay, so what we did here, the same thing we have written here. Okay, so in this way we can get the length of the longest subarray, which is having the two distinct elements, at most two distinct elements. And at the end, what we have to do is we have to just return here. What we have to return? We have to return the max length. We have to return the max length. So in this way we get the answer, and we can also do one thing, that this thing is common in both of the cases. Thing has to be done in both of the cases. So what we can just do is we can just remove this if else blocks, and we can just write this simple thing. So how it will work is that inside this particular condition, we can see here inside this particular condition, what happens is that if the frequency map dot size is already less than equal to 2, it means the window is already valid. Then this particular while loop will not work, and directly this particular max length will be updated, and also the right pointer will be moving ahead, as we were doing in the if block. That we do not have to do with the help of different like else if blocks. And in case if this frequency map dot size is greater than 2, then this first of all this particular thing will be executed, and then only this will be updated, as we were doing in the else block. So this is the code for this. Let's just take the input here, and let's just see if it works or not. So the size of the array is 9, and what are the elements present here? 1 2 1 3 4, 1 2 1 3 4, and 3 5 1 2, 3 3 5 2. So let's just review the code first. First of all, we have just taken the size of the array, and then we have taken the frequency map. What is the purpose of frequency map? The only purpose of frequency map is that we can know the two things. First of all, that how many times every fruit type is occurring inside the window, and second thing is that when a particular fruit type is completely removed from the window, that is when the frequency of that particular fruit type is 0. Okay, so that is the purpose of this frequency map. And here we have just taken the 2 pointers, and then we have taken the max length variable in order to get the update of the maximum length of a subarray. And then we have just run a while loop, that till what point this particular process will be running, where till the point the right pointer is less than n, means it is less than or equal to n minus 1. So what the thing we have missed here, first of all, we have to just go inside the frequency map, and inside that, for the fruits of right, means with the help of right pointer, we have to increment the frequency of it inside the frequency map. Okay, and after that only we can just check for the window validity, that it is valid or not. Based on that thing, we can do whatever the processing we need based on the window validity or for the invalidity. Okay, so at the end we can just return the maximum length. And now we have taken the input, and now just perform a run here. So for this particular input, the result we got is 3. Okay, so the output for this particular input will be 3. So we can see here that maximum number of fruits which we can pick from a contiguous subarray, or we can say the contiguous trees, without skipping the trees, that will be 3. Maximum number of fruits will be 3. Let's just talk about the time and space complexity as well. So here we can see that every element is entering and leaving the window once, therefore the overall time complexity will be O of n. And talking about the space complexity, so frequency map is only holding the 2 different keys at a time, 2 distinct keys, therefore the space complexity is constant in that case. So this problem is done, and this was based on the variable sliding window problem. And now in the next video we will meet with the next problem, that is the longest substring with at most k distinct characters. So this is just similar to this problem only, and just a small variation or a small change in the condition is only have to be done. So this problem we will solve in the next video. So till then, just keep learning and keep growing. This is Aditya Pataria signing off. Thank you.